about one of the most fundamental concepts in mathematics. Sets. Sets are everywhere in maths. They help us organize and group objects logically. Let's explore what sets are and how we work with them. So, let's get started. Do you know what is a set? Yes, a set is a collection of distinct and well-defined objects. These objects are called elements or members of the set. For example, here, the set A contains the element 1, 2, and 3. We usually use curly brackets to read set like this. The set A is 1, 2, and 3. If something is an element of a set, we use the symbol. Do you see in the picture? Okay, in set notation, element means is an element of, like 4 is an element of B. Not element means is not an element of, like 5 is not an element of B. Okay, next, ways to describe sets. There are two common ways to describe a set. Number one is roster form, where we list all the elements. For the example, the set B contains the element 2, 4, 6, and 8. Number 2 is set builder form, where we describe the property of the element. For the example, C is the set of X, where X is an even number less than 10. Okay, next we will discuss about the sets operations. The first one, their union. Let A and B are sets. The union of the sets A and B, denoted by A union B, is the set that contains those elements that are either in A or in B or in both. For the example, set A equals 1, 3, and 5. Set B equals 3, 5, and 6. So the union of the sets A and B in the sets is 1, 3, 5, and 6. Next is intersection. Let A and B are sets. The intersection of the sets A and B, denoted by A intersection B, is the set containing those elements in both A and B. For the example, set A equals 1, 3, and 5. Set B equals 3, 5, and 6. So the intersection of the sets A and B is the set 3 and 5. Okay, next is difference. Let A and B are sets. The difference of the sets A and B, denoted by A difference B, is the set containing those elements that are in A but not in B. For the example, set A equals 1, 3, and 5. Set B equals 3, 5, and 6. So the difference of the set A and B in the set is 1. The last is complement. The complement of a set A includes all elements in the universal set U that are not in A. For the example, universal set U equals 1, 2, 3, 4, and 5. Set A equals 1 and 2. So a complement is 3, 4, and 5. Okay, now we go into the last material, Venn diagram. A Venn diagram is a visual representation of sets using circles. One circle for each set. The overlapping area shows the intersection. The total area of the circles represents the union. and outside the circles represent the complement. For the example, universal set S is the 1 to 8. Set A is the 1, 2, and 3. And set B is 3, 4, and 5. Then set A union B is the 1, 2, 3, 4, and 5. And set A intersection B is 3. Okay, we can see an example of a Venn diagram in the picture. Okay. Venn diagrams are especially useful to solve problems in logic and probability. Next, let's try a few questions together. Okay, let's set A is 2, 4, 6 and set B is 4, 5 and 6. What is A intersection B? Yes, the answer is 4 and 6 because A and B both contains the number 4 and 6. The intersection A and B is 4 and 6. Number 2 is what is A union B? Yes, the answer is 2, 4, 5 and 6 because A contains is 2, 4, 6 and B contains 4, 5 and 6. The union A and B includes all elements from both sets without repetition, which is 2, 4, 5 and 6. Okay, number 3 is what is A difference B? Yes, the answer is 2 because 2 is in A but not in B. The difference A and B is 2. Okay, that's all for now. And thank you for watching, and I hope you learned something new about sets. And see you in the next video. Bye!